Welcome everyone to DJI Enterprises Learning Hub. We are just starting this program, which is the programming basics, and we have Christopher Cousins who will be leading this webinar. And just a little bit of background. First, my name is Michelle Hamilton Cubitt. I'm the president of DJI Enterprises, and we have our DJI Enterprises Learning Hub on our website. You can check us out there. So for career clarity, who we are and what we offer, we're offering courses that are instrumental in assisting students to just test it before they commit. A lot of students are not understanding what they want to do, and so they go through the challenges of going into university or colleges and they start a program and then they're not able to finish it because it's not something that they really wanted to do. So at DJI Enterprises, we are encouraging students to test it before they commit. And with that said, we have practical learning opportunities, we have real world skills, we have empowering decision making ideas on there. And we also have facilitators who have been in the field, in the respective fields. And so they're not just teaching in the classroom without excessive knowledge and skills. So with that said, that is where we are right now. We're trying to encourage students to sign online and also to attend the webinars. We also have interactive sessions like this, and we we want to make sure that you are being equipped with all the resources that are available, and we don't want to leave you stranded. So if you particularly are in a course, for example, an English course online, then we encourage you to attend a webinar and you can have hands-on help with one of our facilitators. Christopher Cousin, he is a full stack developer. He has attained his degree in web designing, and he also have experience in mobile and desktop web designs. And so he also has experience in the industry. He had been exposed to assisting other clients who needed help in that regard. So, of course, he has industry experience. He understands the concepts from idea to development and to deployment, so to speak. And today we're going to just get an understanding of what web designing, programming, and all that is entailed. And this is just a beginner-friendly approach. So it is not an in-depth coverage. But if you find out that this is something you like, then you can also ask us, any questions that you have, and we will be sure to answer them. If you need clear explanation, you can just shoot us an email at info@digienterprises.com, which is info at djjienterprises.com, or call us at 1-844-355-4368, or as we say, 1-844-DJJI ENT. And so without any further ado, we just want to bring uh, Christopher online and so that he can share with you what he has for you today. Over to you, Christopher, and thank you for joining me today.
Thank you, and welcome everyone to the Introduction to Programming Basics. I'm Christopher Cousins. I won't go too much into my introduction since it's been done, and I'll get right into the content. Just going to start by sharing my presentation here. Just bear with me a moment. Okay, just as I share my presentation, it's going to cover the basics of programming and coding, which is the syntax, some languages, and some real-world application and how that kind of falls into place with AI and all of that. I'm just going to open that presentation, then we can get started. Just making sure you guys can see my screen.
Thumbs up.
Amazing. All right. So I'm just going to bypass this introduction as has been done, but just some of my more recent experience. I been a web developer assistant at the Ontario Public Service and a database developer officer at the ANSS or Afghan Network for Social Services. So we're going to go through some prerequisites that you need for computer coding and programming and the skills required to really success in this field. Go over some terms and definitions you've probably heard, some important things to keep in mind when progressing in your learning in coding and programming as that advances maybe into your hobby or career or as it intertwines with your current job and employment. Some differences between words you probably heard, like coding and programming. I'm using it pretty interchangeably here, and we'll go into the reason why. Then we'll kind of get into the fundamentals and core of why you're here, and some more application afterwards. And of course, feel free anytime during the presentation to kind of raise your hand or interrupt me if you have a question or want some further clarity or direction as it applies to why you're here today. So, the prerequisites. Honestly, for coding and programming, now more than ever, there's not a lot that you need beforehand to succeed or even start. First and foremost, you're going to need a laptop or computer, which is not a phone or a tablet or an iPad. The reason being, you're going to need to do some typing and you're going to want to have access to what they call a terminal or a console, which is not available on mobile devices. So even if you're connecting from your phone now, if you have access, even at a library, to have a computer or PC, laptop, more than just an iPad with a keyboard, you're going to want a Windows machine, Mac machine, or a Linux machine. And with that, you're going to need an internet connection most of the time, which if you're here, congratulations. You have all the resources necessary. But a lot of the times you'll find that you don't really need access to the internet 100% of the time when coding. You just need it to install those tools and the actual programming language initially. And some of the skills you need as an individual to succeed. I just have research, persistence, and problem solving. One that you may have thought that isn't included here, which is math or like mathematical knowledge, like a prerequisite in calculus. You definitely don't need a hard skills in math or extensive knowledge in that to succeed or really even start. That's more for very niche, maybe like analytical data science driven field, but you just need research because a lot of the times you're going to be creating things new, exploring new problems, and getting into new things as you are today learning. So having that ability to go out and find information is very important. Persistence, as it applies to problem solving, you're going to hit a wall, as we all do in life, but I find even more so in programming you're going to be kind of banging your head against your computer screen or what have you, trying to solve a problem, figure things out, and correct errors. So if you cannot stick with it, you're going to find some difficulties here in problem solving, which is really the core of computer programming, which is which really doesn't exist without problems because it kind of create came out of a need to solve something as it is. If you need to track your habits, you create an app for that. So the whole field is kind of revolves around solving problems. So it's not much, but they're very core and necessary to succeed here, which is research, persistence, problem solving, and just a computer and a laptop with an internet connection. I just wanted to clarify some terms here that you may have heard or may have some knowledge coming into this. Maybe an employer or teacher has, kind of used these words and you're not sure exactly what they mean or how to pursue or understand them for yourself. So we have coding here. I define that as writing instructions for a computer to operate. So coding is really all that text you kind of see in the Matrix and all those movies is just the text of what you give a computer so that it can run apps. And I differentiate that from programming, which is the ability to plan and create a solution to solve problems in an effective and efficient manner. So where coding, I would say, is the ability to write, I'd say programming is the ability to write well between knowing your ABCs and being able to form words and sentences. if that makes sense. And there's a lot of similarities between language as it is basically in programming, which is language for computers. Um, Hardware and software, which you might have heard, hardware, those are the tangible physical elements of technology and devices. So your physical computer, your screen, that's hardware, as well as the more technical components like you may have heard GPUs and CPUs, as opposed to software, which is what coding is related and interested in, which is those untouchable, intangible units of work that need hardware to exist and run. So, like apps, they don't exist without a computer and a screen and a mouse to interact with it, such as code and data, as you may have your Excel worksheets, Word documents. They don't exist in real life, but they kind of need that hardware to function. And then I included these two for those who are in the field or looking to expand their skill sets, knowledge. Computer science, which is the science of computing, is not actually related to the computers and technology as we know. It really, that's where you might need some math and some background in like calculus and things like that, which is not what we're going to be learning today. But if you've been asked to kind of follow that, that's more of a accredited university or college course, which is now really involved with computing, with coding and programming, but is separate in that nature. So you're really involved with math and knowing if how long it takes to solve mathematical problems. And lastly, I have engineering here, more specifically software engineering, as you have probably heard. And in Canada, that's just a national accreditation title. So that's engineering and software engineering is managed by the Canadian government. And they have a whole site and listing on the details and what it is specifically. I included a blurb here. I'm not going to go into it really, but engineering is a very official title. But as you may see, it's used quite unofficially everywhere. For software engineers, you're not actually going to need a certificate from Canada for engineering. So you might, if you're told to pursue this or looking into it, you're going to want to find out more details if they mean a national accreditation or they just mean that more colloquially and unofficially meaning software developer or programmer. And usually it's the latter. They just need someone who can code and understand apps. Hopefully that's all good. I'm gonna continue on to, oops, actual coding. So coding, which is the language computers use to communicate and do things. So as a language, it has a familiar grammar and rules amongst the different subsets of languages. So you can really think of it like human language. We have, English, French, German, uh, Creole, Spanish, Chinese, all these different languages, but they're all used to communicate similar things. Like we can all tell what time it is, no matter the language, give directions, um, share our personal information, things like that. It sounds differently and it may vary in length, but the information stays the same. So with that, whether you're interested in learning Python, which is a language, or Go, Golang, Java, C, JavaScript, and the list goes on and on. Um, the unifying factor between all of these is the syntax, which is another way to say how the language looks. Like in all languages, you kind of have nouns, which denotes person, places, and things, and verbs, which are actions that nouns can do. And we're going to go in through those similarities of languages here to give you the foundation to go out and learn any one of these, and which helped me to and many other developers switch between them and understand the languages without knowing them deeply. Just a little more information on coding and programming languages as they're called, the different styles of writing it, procedural, functional, object-oriented. Those are a little outside the scope of today, but uh, some things you might want to keep in the back of your head that you'll probably learn if you go deeper into this subject matter. So the fundamentals of coding. So this is the building blocks that all coding and programming languages have in common. We're going to go through execution. And I'll be defining these terms as we go along. Execution, variables, which could be single variables or collections, functions or methods, loops, and conditions. And with those six or seven things, um, that's really the basis and building blocks of all coding programming languages. So, beginning with execution, you might have heard, execute a program or on Windows .exe. That's kind of what code is. It's the verb or action of taking all that written code and having the computer run or perform the actions you've written down for it to do. So a collection of code, which is often called programs, or when you they say ship or deploy or give it to clients or other devices, apps, is executed or run or those instructions are followed by the computer to see the results that you gave it, to see the results of the instructions you gave it. So a nice definition for execution is the initiation and completion of a series of coding statements or instructions. I just want to highlight this little document image. Code is written line by line, just like any English essay or paragraph, and a computer would go down each of those lines, following those steps like a recipe. So execution is the computer following the coding lines or statements that you've given it line by line. And that's what gives you kind of apps like this, even Zoom saying, okay, share the video with everyone, and then, send the audio and video, things like that. Pseudocode. This is just something I want to share with you guys, which is a good way to start coding and getting into that mind of a developer and writing code. So pseudo means fake, so fake code literally. And pseudocode is a way to write code without really writing code, without getting into the nitty-gritty of the language, having to learn all its rules and regulations. It's a way to use plain English or whatever language you speak natively. English is usually used for programming, but I know for international students, it's really hard to learn another language just to learn programming, which is the case many times. So I just have an example here on the right-hand side, this image that says start and then ask user for their name, display hello plus their name and end. So that is an example of pseudocode. This will not work on any computer, but me and you can understand this as instructions. And you can take this as a sort of plan and then translate that into real working code. And the benefits of this is that it focuses on the logic and not the rules. It focuses on what you want to get done, not how it's actually written and done. It really helps to plan and see the any errors or places to improve uh, your code without actually writing code and wasting time doing that. And it makes it really clear to communicate to the others and non-technical individuals like ourselves right now. So even though we can't write out the programs, you can give pseudocode to programmers or developers in your team that you work with, and they'll be able to understand what you mean and translate that into working code quite easily than maybe a document of bullet point uh, requirements. So I just wanted to share a example what we use for start, ask user for their name, display hello plus their name. So in real code, it's a bit longer, especially in a C program here. You have quite a few more lines and it's a little bit more, I won't say overwhelming, but stereotypical as we usually see in TV shows and movies. And there you're kind of focusing on those rules. You have semicolons after each line. And even in Python, it's a little bit more unwieldy. Name equals input, and then those brackets. You're kind of looking at the rules of the language more than the objectives of what you want to do. So that's where pseudocode really comes in handy. We can all kind of read this example and without having any knowledge, and then we can translate it into what we see on this next slide. So moving on to the next unit of coding, which are variables. And these are used to contain data and information within your program to use. They usually contain a single unit of data, maybe like a name, age, maybe a location, time, could store information about their system, could store information about what they want to do. It's just really to store information. They don't perform actions, which is an important thing to know. You can't tell if you had a variable that had their name to um, maybe turn all the letters into uppercase. They don't do things, they just hold information. Important thing to know when getting into more technical and actually writing programs that you have to create variables. They don't just automatically pop up. That's kind of what coding is too. We're doing the automation side, so we have to explicitly make everything, and each variable has a name and their value. So, for example, in our previous one, if we look at this Python code, this variable is name and it contains the user's name. And that's usually a good rule of thumb that you should name it after the information which it would contain. So if it was age, it would be called age and it might hold the number 25, for example. Expanding on variables, it would be quite uh, underwhelming if they can only hold a single piece of data. You would end up with a lot of variables. Say, if you were managing a classroom, for example, to have a single variable for each student would be unfortunate and very hard to manage in the end, having to go through each student step by step or line by line, as they say. So there are two additional sort of types of variables. Uh, I call them listing machines. So list, as you may guess by the name, contains a series or multiple variables of the same or different types. And in programming, they're most often called arrays, collections, or lists. So I have an example of a banana here. It's not a singular banana, but I think they call them fingers, but a bunch of bananas, literally. So that would kind of be a list in programming. So if you want to have multiple students, you could put those in a list and just call it students. And you can just say, or students list in pseudocode. And programmers would understand what you mean by that. Machines, on the other hand, are a grouping of basic variables working together. So in the previous example of single variables, you could have a name, age, and location, and you could put that into a greater variable, maybe called person, which groups it together. So you know a person has a name, an age, and maybe a home address. And so those kind of work together as a singular variable, and you can access that information within it. So you can have like person, person's age, person's home address, person's name. And in programming, that's most typically called an object or class or a dictionary. The reason you kind of get dictionary is because you kind of look up a name and you get the definition. So you have the outer bigger machine like a car, and you can kind of go into and see the subcomponents like tires, engine, headlights, car seats, or the seats within the car, etc. like that. Hopefully that's clear and makes sense to everyone. Kind of have singular units of a variable, and you can expand on that by having a list of variables or a machine variable or object. So halfway there, functions and methods. So these are a big part of programming and coding. This is the kind of the verb of coding that does things. So where variables hold information, function methods do things. So you can have uh, information of a person's name, and now you can actually print it. So printing is a verb, so you got kind of be a function or method. These are quite interchangeable. The difference is very technical, so you can not worry about that too much right now. That's like a computer science definition difference. So function or method, they're really just the verbs that do things. And their main strength is repeating units of work or actions without having to rewrite that line by line. So if you were going to print name, you could write print name and then print the age and print the location. Or you can create a method or function that is print user information that does all of that without having to rewrite print name, print information every time you would like to do that. So this is where we get that really strong feature of coding, which is automation, where you don't have to keep rewriting and redoing the same thing over and over again, where it's kind of grouped in a nice recipe uh, sort of way to save what you've done and reuse that for later on. Conditions. This is kind of where the brains and logic of coding is. Instead of having a different app for every different scenario, you can add branching conditions and options within your singular program. Like you can edit slides on PowerPoint, but you can also present them, and that's not a separate app. That kind of is intuitive to us, but when writing it, you're going to have to sort of think of these things that if you want something different, you're going to have a condition for that. So I just want to go over this image first to kind of expound and explain what a condition is. It's a flowchart. You also see a lot in development and programming. So you're going to start at this red lamp doesn't work. And then we have a condition of is the lamp plugged in? And then we have an option of no, then we're going to plug it in. If it is plugged in, we're going to ask, or there's a condition if it's burnt out. And if it is, we replace it. If not, we're going to have to find some place to repair it. So these yellow diamonds illustrate what a condition is, that it branches or diverges the options or the choices that we make based on a certain situation or what's given as input to that. So that's what conditions are in coding. They change the output or the execution of code based on its input or the situation that it's given. An important thing to note, this is kind of where uh, not so much misconception, but that stereotype of math and coding go hand in hand. It's kind of like logic, but not so much. It's not too difficult. It's just each condition, as seen here, boils down to true or false, yes or no. So the larger the condition, the more complex it gets. You might have to write it down. Like if you merge these into one diamond, it's more unwieldy. You'd have to kind of say, is the lamp plugged in? Is it burned out? Is there power on in the house? It just becomes a little bit harder to track, but definitely no hard maths needed. Sometimes while programming, you're just gonna have to write out each one of the conditions and kind of work it out in your head if that makes sense, and if the action that you're taking makes sense to the situation. Another word you hear from condition are Booleans, which is another word to say true or false. And that's what they have to boil down to, true or false in the end. So is the lamp plugged in? Yes or no, not. Uh, can't even think of an example, but like, why is the lamp here? Kind of doesn't make sense. So just gotta kind of make sense in that way. Question that boils to yes or no. Moving on to loops. So as the name kind of implies, hopefully, it's a way to repeat or cycle the same code, kind of like a function or method, but within loops, you can use all the other units of code we covered, such as variables, so you can store data within a loop, use functions and method as well, so we can do a function and method of repeated amounts of times and have conditions within it. So even though you're going through the same code, what you do may change based on the amount of times you've repeated it. So it can repeat for a set amount of times, like 10 times, 15 times, 100 times, or it can repeat based on a condition, like as long as it's day, continue to keep my light on or turn on the light, or as long as the temperature is below 15 degrees, increase the home's temperature by 1 degree. And anything can be looped, kind of like I said, you can store variables in loop, use functions or methods within it, and have conditions that change what the loop does on each iteration or on each cycle of it. So these are just some pseudocode examples. Looks a little bit more complex, but they just explain each type of loop I said. Like we have a fixed loop that says for I, which is just a way to say for each iteration from 1 to 5, do display the iteration number plus the actual number that they're on. Um, a temporal or time-based loop where you get the current time, set the start time to the current time, and then while the current time minus the time you started, which is a way to do math. Yeah, not too hard. So you're just kind of getting the amount of time that's passed. And if it's less than 10 seconds, say that you're waiting. And then after 10 seconds, you display that that time has passed. And then a conditional loop here where we have user input not equal to exit. Ask the user for their input and kind of just say you typed, and then you just say what they typed there. Pretty simple. Hopefully you're following along with these pseudocode examples. Just reading them out should be able to tell you what it is. And if you can't kind of get it, kind of simplify it to more plain English. And then you have pseudocode when anyone can read it and get the gist of what you mean. So these are those three types of loops. Fixed loop based on a certain number, uh, temporal based on time, and one based on a condition, an arbitrary condition, really.
Christopher, can you explain when you would use these examples?
When?
Yes, like
So, between a fixed loop, temporal, and conditional, it really depends on what you're building. So you might have a fixed loop if you know the number, like if you're doing home automation and you know you have 10 lights, you may want to flash each light, you may want to like flash each one for the number you have. So if you have 10, you might go through each 10 and say flashlight number one, and then go and flashlight number two, so on and so forth. And then time based might be in the home automation example again, check if it's 8 p.m. If not, turn on your lights. And then after, wait, time based. Sorry, that's the condition. If it's time based, you might want to say, as long as it's before 8 p.m., increase the heat because maybe you like to wake up hot, or that helps you to wake up, or 8 a.m. rather. I don't know who's waking up, 8 p.m. And then conditional, which is more prevalent, because it can be based on anything, and that's kind of more flexible with the needs that we have here. You can base it on whether you're home, you might want to turn on your radio, start playing some music, or you can have it based on a condition, maybe if, I don't know, if it's raining outside, you might want to close all the windows and blinds if they're automated like that. Does that make sense and answer your question?
yeah, so you're saying that these apps or these automation opportunities are used in devices that are automated. So basically, the programming is set in such that it is designed for automation on a specific app. For example, we have Nest, which is the automation for heating system. So they give you the option whether you want to turn it on at a certain time. Like say if you're at work and you want to be in a warm house by the time you get home, you would set the heater to turn on by 5 o'clock. So within an hour when you get home, the house is warm. So I guess what the person who did the programming did prior to setting up that system is to give you the option to have the settings set in an automated way. So then this program, what you're describing, is a precursor to what we now have as our home use. Is that what you're describing? And then there are different options to the different type of, you could say, programming or programs that are available for the end user.
Yeah, a little complicated, but when you're giving so many options to a user, essentially, yes, accounting for the different options and ways to automate. In this example of home automation, but it definitely applies to other things like web development and databases and maybe even programming devices like keyboards. You're really just trying to account for ways to automate and kind of lessen the load that the user has to do.
Okay, interesting.
Okay,
Thank you.
no problem. Glad that answered your question. We'll continue then to the application. So we covered all the parts of coding, the variables, execution, conditions, loops, and functions and methods. So I definitely want to give you guys some examples of where you can use this, which kind of ties into your question you had before of of its use, really. So I just have three example images that I'll go through. You kind of have an Excel spreadsheet here on your left, computer programming on the bottom right, and some web pages. And I just want to highlight, maybe depending on your field and career, I don't know how much word processing or document management or formula and spreadsheets you use, but many of Word, Microsoft Word, or Office 3, whatever they're calling it, Office 365, Microsoft Word, Copilots, they all have extensions you likely use, and they have a thing called macros, which is a way to program and add functionality that you specifically, or maybe a set or field of people may find useful and use, such as many of the formulas, even in Excel, is a way to program to an extent. And even now, Excel actually became a programming language. So those if functions and formulas, sums and aggregates, with this understanding, I hope you can go in and kind of have a better understanding and application towards it to a more complex and relevant formulas or even macros and extensions for Excel. And more than just Excel, many apps that we use and games, if you play games here, have what they call plugins, which is a way to add external programs into their app and kind of plug that in to be used. And they use various languages, many Python, some JavaScript or Lua or Perl. So you can add, maybe there's a feature that was really missing and they never added an update. If they have the option to have plugins, you can learn the language and add that feature you always wanted, granted that the app allows for that. Like extensions in your browser, those are all coded and programmed in by kind of volunteers or people who saw the need and made the app for it. The top right with the websites is another popular use for coding and programming, which is web scraping as they web scraping as they call it, which is a way to collect information and data from websites at a large volume, maybe dozens, hundreds, thousands, millions. Most famously used for training our AI that we have now, which just basically got every web page on the internet, took the data and fed it to machine learning. So for us, maybe you host a blog and you need to stay up to date with maybe whale migration. You can definitely create a script to kind of extrapolate relevant information from those web pages or news articles or whatever website you have on the internet. You can definitely automate a script to get pieces of information that are relevant to you and kind of transform that into a data or a sheet that is useful to you. And lastly here, which we're going to go a little more in depth in, which is AI or pair programming or vibe coding, as they say, which really helps us to create even better apps at a starter and beginner level. So some more applications, so vibe coding. Some of these AIs you can use, which you can use, and I recommend like ChatGPT, most popular, Claude or Claude Code, as I say, Google's Gemini, Replit, which is a mobile application, so you can even create apps on your phone or scripts on your phone. Uh, GitHub Copilot, which is a little bit more technical, where you're going to be writing code and it's going to help you print and write code as well. Bolt.new, and there's thousands and thousands new models in AI every day, but those are some of the more popular and time and user proven apps. And then for uses, using kind of the fundamentals we have while learning a separate language, for you, kind of workflow automation, which is a big thing that really pushed this move to learn how to code and program. You can manage and create documents on your computer or even on your employer's network and computers and kind of help in their workflow there. You can definitely code and edit to manage your videos or photos for, maybe compress their sizes, even do some simple or advanced photo and video editing. As I said as well, web scrapers and program macros or plugins, or which is ways to add functionality and features to existing apps and games. And some people call them mods as well. Some extra resources. So now that you know the core building blocks and fundamentals, here are just some uh, additional resources in addition to DJJI that you can consult to go further in a certain language or a certain domain, such as web development, game development, backend development, database. Uh, Lynda.com or LinkedIn Learning, which is pretty popular, which has more than just computer programming, but various other uh, topics as well, which is free with your school and some library cards as well. YouTube or University YouTube by Google, which has, everything you ever need for free, really. There's some great Code with Me challenges, channels that feature different people building different apps and projects, which you can learn from. Or if you prefer hands-on practice, I recommend starting with Python or JavaScript, which are simple and easy to use languages where you can see the results pretty quickly and get yourself comfortable on programming. And if you have a specific goal in mind for a professional venture in software development, roadmap.sh or .sh uh, has a roadmap for various professional titles like developer operations, database, backend, mainframe, and it has all the modules with information and projects that you can work on as well. So I'm just going to finish this presentation on a very important note that I definitely don't want to miss out, which is machine learning and AI, which really kind of changes the narrative and even how we look at coding and how many people say that it's, not just removing jobs from software developers, but across the whole field and kind of why bother to code now. So some pros and cons of coding with AI. It's fast. It's fast. It knows a lot, knows everything, quote unquote. It's generally available at any time of day across wherever you are in the world where people aren't. It can be unbiased and objective, and usually is most times. And it enhances your abilities, not just the code, but in every aspect of life. You can use it to ask how to tend to your plants, best way to get rid of grinds and stains. It knows everything, basically. And here I put as a pro that it takes away the previous work of software developers and engineers, which you may see as a con, but the more tools and help you can get, the more time and availability you have to focus on other things you enjoy or things that are more important or complex that you couldn't because you were kind of tied up in the menial. But there are cons to AI, which may not, you may not know or is not advertised or publicized as much, depending on, the sources you listen to. And that's the cost. And you may or may not know this, hitting your limits with ChatGPT or whatever free model you have in your search engine, that if you want better results, it costs money. And the more information you want to give it, the more it's going to cost you. And that's kind of why it's not adopted so much for individual people. And that's the kind of cost benefit analysis employers make between keeping their human employees, which have their salary, versus how much it costs to kind of run these models for them. And it costs time too, because though it can do it for you, you still have to prompt it. So you have to ask the question still. It's not just gonna automatically know your business model, know your whole life story, and give you what you want without asking for it. And the time comes with, in this last point here, output is based on prompt quality, that you're gonna have to tell it what you want. And if it gets it wrong, you're gonna have to ask it in another way, give it more information, give it more constraints, even give it more context. And that comes with time because you gotta wait for its response. Even though it's fast, you have to read and understand it too.
Well,
Hallucinations,
mhm.
what they say, which is when it kind of makes stuff up. It's definitely getting better in that regard, but definitely gotta double check its work. And the output it gives you, make sure everything's correct. And, if you're generating images before, make sure it has the right number of fingers, things like that. And lastly, I have ecological, if that matters to you. Running these models, takes a lot of energy, keep the CPUs cool, and, not the greatest environmental impacts. But leave it off why you should code. It helps you understand what AI produces, especially because it's a product of software engineering and programming. So knowing how to code and how to program helps you understand it, which helps you understand what it gives you, which can help you give it better prompts to get better results for yourself in the end. Help check and verify its results it produces, and it enhances your ability. It's not something to definitely be afraid of. It's definitely something to use as a tool. Like, no one's getting applause for, you know, hammering in a nail with their own hands. We have these tools for our use to make our lives easier. I will say though, when using AI to generate things, it definitely trivializes the work, as I said before. So simpler apps, if you have an idea in mind, maybe for home automation, maybe for a script or workflow, I would go to AI first to see if it can create that for you. Save your time. Don't have to learn a whole new language, write and debug scripts all day. It can do pretty well. Maybe if you have an example Excel formula or uh, home automation or a simple like web page or app in mind, see what it can make. And more often than not, it would do pretty well. But when it comes to maybe creating an enterprise or business, uh, orchestrating multiple services together, like if you want to search on your OneDrive, then send an email and that controls something in your house, when it has a lot of moving parts, I would definitely say you're going to need to learn how to program and do those things together because AI doesn't have that context yet. It's getting more integrated, but it doesn't know everything and it can't actually produce and ship those things. Like it can't send an email, but it can draft the text. So with that, that's all I have for you today. If you have any questions, please let me know and thank you for listening.
Well, thank you so much, Christopher. It is a lot more than I thought. I had no idea what computer programming really was. I do understand that it is a language and it is a different kind of language and it's a computer language. So if anyone have any question, okay, I see someone clapping. Round of applause. Thank you. Um, do you have any question, anyone? Isaac, do you have any questions? Well, okay.
With AI becoming more prevalent, are jobs in coding becoming more competitive? Um, I'll say software engineering and software development's always been, at least in my experience, very competitive. I would almost say maybe it's become I I wouldn't say it's changed much. It's just added a new competitor. Now it's not just the person you graduated with or the other people on the application. You're also competing with AI. I definitely think the intensity is there as it's been before. but not more competitive. It's always been pretty competitive. Hopefully that makes sense.
Okay. So thank you so much, Christopher. I really appreciate your contribution to this webinar, and I do hope that we can work together in the future, maybe part two. And I do appreciate all that we have been able to accomplish so far. And as we always say, this is one of the things that we're trying to do to encourage students to just test it before they commit. And if they're able to test different paths and different careers by taking even a course that's available, and then they can go from there to aspire to a whole college or, or university degree, then that will definitely help them. But what we have seen so far is a lot of students are not being in a position to understand what they really want to do. And so, with that said, we wanted to make sure that we bring to the table opportunities for students to test it before they actually commit. And if this resonates with you, please feel free to share your thoughts. And also, if you know anyone who is struggling, please feel free to also let them know what we're offering on Digi Enterprises website. And so thank you again. Oh, so here's another, okay, so here's another question. Sorry about that. Are you of the view that AI will replace humans?
Um, in context of coding and programming, maybe one day. Uh, maybe one day. Not entirely. Uh, definitely it's getting there that they're replacing definitely the entry level jobs. Maybe some of because more of the junior roles are to code instead of programming, which is the problem solving area. AI is definitely not at that point to kind of draft solutions to maybe a business's problem or uh value value perspective. Like if you were to kind of create a new application like React, which is a framework, I don't think it would do that, but it can definitely do the kind of grunt work. If it will replace people altogether outside of this, I don't know about that, but in terms of coding, I think it could get to a good point where there's only a few developers that really manage and continue to evolve and upgrade and update that AI to even better standards.
Yeah, because you do need web developers to be able to improve or even evolve AI. So if they're not available, then who is going to do that? So someone is necessary to work behind the scene. And I know a lot of people have said that in certain industries that humans are not needed anymore. And I would say maybe in the teaching industry to be specific, because people are utilizing AI to teach them now. And also what Christopher said with regards to opportunities online, people are, using YouTube as a way of informing people. So then people don't necessarily need to go into the classroom, but there's still a human need to socialize with other humans. So you can't just rely on AI or just a screen. You have to understand that because some people are, I think it's called kinesthetic learners. So if you are not able to learn by just images or just by information in words, you're going to need hands-on information. So, and I'm not sure what percentage of the population that is, it could be maybe one third because we have the three opportunities, audio, the visual, and then the kinesthetic. So if we have a third of each group, then we will definitely need at least a third of the population to require hands-on in opposed to AI teaching them, unless they have a robot that will replace a person. But still, people still need to socialize. Okay, is there any other question or any other? Okay. All right. Thank you again, Christopher. And it's a pleasure having those of you who have been able to join online, thank you so much. And for those who have been able to join later on, because we're going to be posting this video on our website. And if you are able to watch this later on and you don't have Christofer physically available to answer your questions, I propose that you still reach out to us by calling us at 1-844 DIGI ENT, that's DJJI ENT, or 1-844-355-4368. You can also send us an email at info@digienterprises.com, which is DJJI Enterprises with an S.com. And just go on our website, www.digienterprises.com, and just send us a note, reach out to us. You can subscribe and just send us your email and then we'll respond to you. So without any further ado, thank you so much again for joining us and have a wonderful day.